Hey, what's up everyone, and welcome to our course on how to become a blockchain developer, where we'll take you step by step from beginning to end on learning the skills needed to become a blockchain developer. In this course, we'll take you through understanding the ideas and concepts of blockchain technology to building out your very own applications using it. Over the past few years, blockchain technology has changed dramatically, and we're now seeing things like infrastructure and applications now being built on top of it. With this evolution in blockchain technology, it is now opening up careers and jobs in the space, and this course was built to provide you with that knowledge and the skills to jumpstart your career becoming a blockchain developer. And in this course, again, we're going to take you step by step, first kind of going over the concepts of what blockchain is. We'll then go into how to create and build smart contracts, which are small programs that are built on top of the blockchain, and finally end off this course by showing you how to take those smart contracts and build actual working web applications that you can deploy and have users use on the web. Now, this course was structured in distinct but interconnected sections. So down below in the description, you'll find timestamps that will help you navigate to certain sections of the course. That way, if you need to take a break and come back to it later, you can always continue off where you left. Or if you want to skip ahead and just learn about the things that are interesting to you, you can use the timestamps in the description to find the section that you want to start with. Quick breakdown of each section. We have 3 sections of getting started, then a deep dive into smart contracts, and then deep dive into building out applications. In the getting started section, we're going to go over the high-level concept of this new technology of blockchain. We'll kind of start at the very top with the new era of Web3, and then kind of describe a little bit more about what is a blockchain. Following that, we'll go over what are smart contracts and why are they so important to blockchain. We'll also go over something called wallets, which is a very important part of how to interact and use the blockchain. And we'll do an overview of a tool called ThirdWeb, which is a full stack framework allowing you to build out your blockchain applications quick and easy. The next section, smart contracts, will take a deeper dive into what smart contracts are, how they work, and how to create your very own smart contracts. We'll actually be deploying your very own smart contracts through ThirdWeb, which don't require any coding knowledge at all. And we'll show you how easy it is to create certain contracts that we have pre-built, and you can just, with a click of a button, deploy them onto a blockchain. We'll also create and customize our very own smart contracts and cover some basics in Solidity, which is the programming language used to code these smart contracts. We'll also be going through some of ThirdWeb's tools like our dashboard and showing you how easy it is to use our UI to manage and control your smart contracts that you have deployed. In the final section of applications, this is where we're going to take those smart contracts that we deployed and build some front-end applications that are going to be usable by any user that uses our web app. And we'll be creating these applications again using ThirdWeb's SDK, which makes it very quick and easy to implement and interact with smart contracts and the blockchain through your web application. So again, the way this course is structured is into those 3 main sections, and depending on where your skill level is already with blockchain, with understanding Web3 and blockchain technology, you can skip ahead to the section that fits your interest and knowledge the most. The recommendations that we'll give is use the getting started section if you are unfamiliar with blockchain and Web3, or if you want to learn a little bit more about the high level concepts of this technology. But if you're already familiar with the high-level concepts of Web3 and blockchain technology, you can skip ahead to the smart contract section where you'll learn how to build out your very own smart contracts that you can use on the blockchain. And again, the application section to build front-end applications. You can even skip ahead to that if you're not very interested in building out your own smart contracts, but just wanting to learn how to implement and interact with smart contracts while building front-end applications. You can skip ahead to the application section to build your very own Web3 or blockchain app. But again, all the timestamps will be down in the description, so you can follow along, take a break, take this course at your own pace. And by the end of it, you'll be able to have your very own Web3 blockchain application, some smart contracts, and you'll have the knowledge on how to use ThirdWeb to build out all of these applications. So with that being said, we'll start off with our first section of getting started, where we'll take a high-level look at the concepts of Web3 and blockchain technology. let's start off by understanding a higher level of Web3 and blockchain technology. Now, you may have heard the term Web3 used out in the world before, and if you haven't, it's okay. We'll kind of go over that in this section. So many will categorize Web3 as the next era of the web or the internet. And to get a better understanding of Web3 in the next era, it will be a lot easier to understand the eras that came before in Web 2 and Web 1, so we can see the evolution of the web and where it's headed to. So we'll first go over the very beginning, which was Web 1, and this was the information era of the internet or the web. In this era of the internet, it was mainly static web pages, and it was really a read-only type of web where you could retrieve information and see it or read about it on your screen, but you couldn't really interact or do anything with it. It was really just a library of information that was available on the internet. Now fast forward and we enter the era of Web 2, or the social part of the web. And this is the era where we now have applications, and this includes social media applications, blogs, e-commerce. And what this introduced to the web was now the ability not to only read and view things, but to interact and write things on top of the internet. Not only can people now visit a website just to read information, but we can now interact with one another or that information on top of the web page. We can leave comments, we can shop and buy things online, we can even interact with one another across these applications. We now don't only have static web pages, but dynamic web pages that allow these interactions to happen. And the era of Web 2 we are still currently in, and this lives through all those applications that we just spoke about. Now introducing this new era of the web, or Web 3, also known as the decentralized web. And again, if we look back at Web 1, which was the ability to read information on the web, we look back at Web 2, which was the ability to read and write information. Web 3 introduces a new concept of ownership, of digital ownership. Now you may hear a few words that get thrown out there when associating with Web 3. You may hear things like blockchain. You also hear things like decentralization. And really what this is Web 3 is built on this idea of blockchain technology and decentralization, which we'll go over a little bit more in detail in the next section when we talk more about blockchain and how it works. To get a better understanding of the new era of Web 3, we are now having ownership of digital assets. And what makes this possible is blockchain technology. And because of this new technology, we can now own things like NFTs, cryptocurrency, which are these digital assets that don't really have a physical connection to the real world, but they do live on our devices, whether it's our computer or on the web and on our mobile devices. This new technology allows us to prove and verify this digital ownership. So when you hear someone talk about Web 3, this is normally what they're referring to, is this new era of the web that we are now moving into and we are now starting to see. And to speak a little bit on the decentralization part, if we look at Web 2, we live right now in a very centralized system where all of our data and information is held by these single servers or data points. And if something were to ever happen to them, one, all of that information would be lost or we wouldn't be able to retrieve, but whoever owns that single point of data now has ownership and has the ability to do what they want with that information. With decentralization, instead of having one single point, we now scatter this amongst different people in different areas, now allowing our data to be decentralized, meaning that not only one person has the ability to control our data and information, but now in a decentralized network, users can now have the ability to have ownership of their own data and digital assets. And continuing on this high-level concept of what Web 3 brings and what this new era of the web is introducing, one of the things that we just went over is, like we said, was decentralization, which is reducing our reliance on these single centralized areas and data points. It also introduces interoperability, which is a brand new thing that we weren't really able to do previously because of decentralized data sources. In a Web 3 or decentralized web, All of this information is publicly accessible on top of a blockchain, meaning that I could build one application here that retrieved information and build another application as well that could receive that same bit of information, allowing them to work together seamlessly without having to build a connection between both of those applications. Web3 also introduces enhanced personalization. Because the data is decentralized, now users have the ability to control their own data. What happens to it? Where does it go? Who can use it? Because you now own your information and your data, you can now personalize your own preferences and services based on your needs. So to summarize everything that we just went over and to bring it all in, why Web3 is so important is one, your data privacy and security. Again, because of the decentralized web, you now have ownership and power over your own digital data. Decentralization, not only is your data now not held by one single data source, it is now decentralized, meaning there is no one failure point to your data source. So if one piece of the network goes down, you have these other pieces there that have the ability to still retrieve that same information. And that goes over the high-level concept of what Web3 is, which is a term that you might hear often. Next, we're going to dive into understanding a little bit more about what a blockchain is, which is the core piece of technology that makes this idea and concept of Web3 possible. Now that we have a better understanding of the next era of Web3, let's now talk about what makes digital ownership possible. Again, like we went over in the last section, Web 1 brought us the ability to read information on the internet. Web 2 brought the ability to read and write, which meant interacting with the internet. And Web 3 brings this idea of digital ownership, being able to own a digital asset. And really what makes that ownership possible is blockchain technology. And in this section, we're going to take a look into what is a blockchain, how does it work, and really start to understand the concept and the idea of this new piece of technology. So an overview of what we're going to cover in this section is we're going to take a high-level look of the idea and concept of a blockchain. We'll then take a deeper dive and get to know some of the technical terms of how a blockchain works. Then we'll kind of give an examples to help you visualize and understand how a blockchain works. And we'll go over some of the blockchains you may be familiar with, like Bitcoin and Ethereum. Let's first start off with a high-level view of what a blockchain is. Now, you may have heard the term blockchain used before. A lot of times you may hear it in reference to something like cryptocurrency or NFTs. Cryptocurrency being a digital currency and NFTs being digital assets. Most of the time it's associated with something like an image, a picture, or some type of media. But really, in order to have those two things, cryptocurrency and NFTs, the underlying technology beneath all of that is something called blockchain. And blockchain is what makes digital ownership and ownership of these digital assets possible. Now let's take a look at the name blockchain. We have block and chain, and essentially these two words describe how a blockchain works. These blocks equal the transactions or the information that we need to store, and we link these blocks together and we create a chain, allowing us to create what we call a digital ledger, which you can think of just a list of transactions and interactions and data that is being stored on a blockchain. So there are a few things that a blockchain allows us to accomplish. One thing that you may hear a lot, and we talked about in a previous section, is something called decentralization. And instead of having one data source that holds all this information, this digital ledger is now spread across different computers or nodes that hold a copy of this digital ledger. So unlike a centralized system where if that data source goes down, you would lose all your information, in a decentralized network, if one node goes down, you still have the other nodes that carry that same information as well. Along with a centralized data source, the owner of that centralized data source now has the ownership and control of the data that it holds. Whereas in a decentralized network, no one node or computer has the ability to override or overrule any of the information on a blockchain. Blockchains also provide transparency and anonymity, meaning that any of these transactions or interactions that get logged onto a blockchain are viewable by the public. Anyone can go onto any blockchain and look at all the transactions and the information that is being stored on it. But along with blockchain comes the ability of anonymity, meaning that you don't need to fully identify yourself in order to interact or store data or have information stored on a blockchain. Another important concept of blockchain is immutability. Any information that is put onto a blockchain is immutable, meaning it can't be changed, edited, or removed from the blockchain once it has been written to it. And this goes to the transparency part, where once something is put onto a blockchain, you can't edit it and you can't make changes to it. There's no tricking people with information and putting out malicious things out there to try and trick people and then changing the information on the blockchain. Everything is transparent and you can see everything that happens on top of it. So again, a very high level look at the concept of blockchain. We have these blocks that hold information that is transparent, immutable, and you have anonymity to it, and these blocks are linked together to create a chain, which forms our blockchain, which is a digital ledger of all these block transactions, and that's how we get the name blockchain. So the idea that, a blockchain is just a database holding all of the information of interactions or transactions that happen between two parties, if you can visualize that, that is kind of the high level concept of what a blockchain is. Now, I know that could be a lot to take in, especially if something like blockchain is new to you. But what we're going to do now is take a little deeper dive into the technical terms of blockchain and kind of get more specific on exactly how blockchains work. So again, we talked about the idea of these blocks being linked to one another. In a block, you can think of it as a transaction, and that block holds transactions and their data and information of what is happening. So that data could include who the sender of the transaction is, who the receiver of the transaction is, and what data is being either stored or transferred between these two parties. And also within this block is a unique hash that identifies this block of transactions along with the hash of the previous block that it's linked to. And it's with this connection of having the previous hashed block that these two blocks are now connected, and this forms a chain, therefore forming the blockchain. Now, why is having that previous hash so important? This helps the blockchain become immutable and essentially makes it so that you can't change the information or data on top of the blockchain. Because if I were to go in and try to change the information of a block that already exists, if I change that information, the cryptographic hashing that gives it its unique hash would have to change on every block after that. Now, to add a block to a blockchain, many blockchains have something called a consensus mechanism or consensus protocol. And what this consensus does is validates the integrity of this transaction or block that is getting added to the chain. Ideally, multiple nodes have to agree on consensus in order to add a new transaction or block. No one node can just independently add a block to a blockchain. They have to go through this consensus mechanism or protocol in order to check the validity of it in order to add it on. Now, there are many types of blockchains out there, each with their own consensus mechanism or protocol, along with utilities and different services that each one of them provide. A few common consensus protocols that you might see is something called proof of work, which is something like the Bitcoin blockchain works off of, or something called proof of stake, which is something that Ethereum's blockchain just recently moved to. So again, a quick overview of the technical side of blockchains. You have these computers or nodes that form your decentralized network of a blockchain. You have blocks that contain information of the transactions along with a unique hash and the previous hash of the block before it, allowing it to connect to one another, forming a blockchain. And we also talked a little bit about the consensus mechanism and protocol, which allows these nodes to verify the integrity and validate the transactions of these blocks getting added to a blockchain. And again, this is a lot of information to take in, and it is a new concept that makes this idea of blockchain and blockchain technology unlock a possibility of digital ownership. And the way it's able to do this is because we have immutable data that is stored on the blockchain. We know for a fact that the data that is on this blockchain is true. No one can tamper with the data and create information on a blockchain that isn't true. Everything has to be validated through a consensus mechanism, and everything is transparent and viewable as far as the data goes stored on a blockchain. And it's with this idea that we're able to have something like cryptocurrency, a digital currency. We can transfer peer-to-peer. No one can fraudulently say that I have more of this digital currency than I actually own, because again, everything is on the blockchain and all previous record of this digital currency is recorded on it. And now hopefully this explanation of blockchain is making sense, but we'll kind of go over a metaphor and example of what a blockchain is and how it works. So in this example, let's imagine a digital library. This library is your blockchain, and in this library we have a bunch of books with information in it, and these are going to be your blocks or your transactions, your information that is stored on your blockchain. All of these books are aligned in order and you know what book came before it, because in each book it references the book that it is connected to. And let's say we have book 5. In book 5 it'll say before this book came book 4, and that way we know where to place the book within our library. And this again is referencing each of these books being blocks or transactions and them linking together to create this library of information stored on our blockchain. Now anyone can come into our library and pick out a book and read the information and data that is on top of it. This equates to the transparency that blockchains have, where anyone can view any of the previous transactions and the history of data on top of a blockchain. Now we want to add a new block to our blockchain, in this case a new book, and we wrote some information and some data that we're going to store in this book and put into our digital library. Now what forms this library is our librarians, and these librarians equal our nodes or the computers that create our decentralized blockchain. And in order for us to add this book into our digital library, we have to now get approval, and these librarians need to verify that the integrity of this book is valid and that it is okay to add to our digital library. And this goes to the reference of we have these digital nodes with a consensus mechanism that they need to verify a transaction or block before adding it to a blockchain. So once it is valid, we can now add the book to our digital library. That new book has a reference to the previous book before it, so we know in what order our books need to go within our library. And again, anyone can come into the library and view and read all of the data within our books. So again, we have our digital library representing our blockchain, those books representing the blocks or transactions that we are adding to our blockchain, and the data inside of it references the data that we are storing on the blockchain along with the previous book that came before it, so we know the order of these transactions. And the only way to add a book into this library is to get it validated by the librarians that run the library. So I hope that metaphor explained it in a way where blockchain technology makes a little bit more sense. And again, we went over a high-level look of what blockchains are, and we kind of covered the technical terms that you may most likely see when dealing with blockchain technology. Now, we did mention it a little bit earlier, but there are different types of blockchains out there. One of the most popular blockchains that you probably know about is something called Bitcoin. And now Bitcoin was the first blockchain project that we saw come out. And the white paper for Bitcoin was written by Satoshi Nakamoto and was published in 2008. And really what Bitcoin is a blockchain for a store of value. On the Bitcoin blockchain, there is this cryptocurrency called Bitcoin. And the idea and concept behind Bitcoin was the ability to have peer-to-peer transactions with a digital currency. And like mentioned before, Bitcoin does work off a consensus mechanism called proof of work, which requires something called miners to basically solve these complex math problems to verify these transactions on top of the blockchain. And for supplying the computing power for solving these math problems and maintaining the blockchain, they are rewarded with some of this cryptocurrency. And you may hear a lot of people say that Bitcoin is a digital gold because essentially Bitcoin has a hard cap of the total amount of supply that will ever be created or generated. And once it reaches that hard cap and that supply, that is how much of that digital currency will live forever on that blockchain. Now, other than Bitcoin, you may have heard of another popular blockchain called Ethereum. And the Ethereum blockchain was introduced by Vitalik Buterin in 2015. And what Ethereum aimed to bring to blockchain technology was not only the ability of the store of value, because the Ethereum blockchain still does have a digital currency called Ethereum that you can do peer-to-peer transactions with, but it also brought utility and an application aspect to blockchain technology. So now not only could you allow these peer-to-peer transactions, but you can also create small programs or pieces of code that you could store on top of a blockchain. And these programs are something called smart contracts. And in the section after this, we're going to take a deeper dive into what smart contracts are and how they work on the Ethereum network. But ideally, Ethereum's blockchain was created with a different goal in mind. Again, it has a store of value and the ability to create utility. So unlike Bitcoin's hard cap of a certain amount of digital currency being made, network has no hard cap on the amount of digital currency that it generates. But because of the utility that you can build on top of Ethereum, it requires the usage of this digital currency in order to work. Because on Ethereum's blockchain, we introduced this concept of gas. Basically, anytime you want to write or give information or transact information on top of Ethereum's blockchain, you pay something called gas, which is like a transaction fee that you have to pay with Ethereum's digital currency. Now, when you pay with this digital currency, it is destroyed, or the term that we will normally use with blockchain development is burn. So when we burn this digital currency, when we pay for this gas fee, it is destroyed forever and there is no way to retrieve it back. And because of this gas fee, unlike Bitcoin where it has a hard cap in the amount of digital currency it supplies, Ethereum does not, because it is essentially burning away and destroying a part of its digital currency every time something is transacted or interacts with its blockchain. But again, you can create this utility on top of Ethereum's blockchain through the use of something called smart contracts. Now in this course, we will be dealing mainly with the Ethereum blockchain. And this is because, like we just said and stated, you can create utility or applications and use cases on top of the blockchain. Now, Ethereum did also create something called the EVM, or the Ethereum Virtual Machine. And basically what this allowed you to do is create these smart contracts for the Ethereum blockchain. Now, if you do a little bit more research on blockchains, you may see other blockchains out there, and what you may also notice is a lot of these blockchains are actually built on top of Ethereum's technology. And what you also may see is that a lot of these blockchains are what are considered EVM compatible. And that means that they are all compatible with the Ethereum blockchain and with one another. This means I can create a contract, or let's just say right now, a program for one blockchain that is EVM compatible, but I can also deploy that same program on any other EVM compatible blockchain. And this will also create the interoperability and connection between all of these EVM compatible blockchains. Even though they may be different blockchains, they still have a way to communicate with one another. This also means as a blockchain developer, if you choose to build on one of these EVM compatible blockchains, but then choose to move to another EVM compatible blockchain, you can keep all of your smart contracts or programs that you wrote for one chain and move them onto another, and they will work the same way. So again, in this course, we will be dealing with EVM compatible blockchains. There are other blockchains out there, but EVM compatible blockchains are the most popular blockchains in use. Now, we covered a lot in this section, from a high level view of what blockchains are to a more technical view and kind of getting familiar with the technical terminology of what blockchains are. And we went over some two examples of blockchains, being one in Bitcoin and the other in Ethereum, which we are going to be dealing with the most within this course. We also covered EVM compatible blockchains and why they are so important. And again, that is what we'll be covering when developing our own smart contracts and our blockchain applications. Now that we know a little bit more about blockchains and we know a little bit more about the Ethereum blockchain and EVM, let's now jump into our next section where we'll talk a little bit more about smart contracts, which are these programs that you can create and deploy onto a EVM blockchain, which allows you to execute these certain utility and functions on top of a blockchain. Now that we have a better understanding of blockchains and what they are and how they work, we'll now go into learning a little bit more about smart contracts. In the last section, we covered the Ethereum blockchain and how they introduced the utility aspect to blockchains. And that utility is made possible through these things called smart contracts. And in this section, we're going to cover smart contracts similar to how we did blockchains. We're going to first take a high-level look at the concepts of smart contracts and how they work. We'll then take a deeper dive into the technical side of smart contracts, and we'll also use a metaphor to help you visualize exactly how smart contracts work. And then lastly, we'll cover some of the programming languages required to learn how to create smart contracts. Now again, we're not going to go into exactly how to create smart contracts in this section, but more so cover the high-level concepts of what smart contracts are. In the next large section of this course, we'll be going more in depth about smart contracts, how to deploy them using Third Web, and how to even create your very own smart contracts and deploy them as well. This section is more so for the understanding, so we understand the conceptual idea of what smart contracts are. So let's first take a high-level view of what smart contracts are, and we kind of covered it in the last section. On the Ethereum blockchain, we have this ability to now add utility and applications through these smart contracts. Now, if we look at smart contracts, we can just look at the word and they are contracts. And if you are familiar with contracts in the real world, they are normally a legal binding document between two parties agreeing to do something. And these agreements might have certain obligations, they might have certain terms you have to follow, as well as certain conditions that need to be met in order for the contract to be valid. And normally with a real world contract, you normally have a third party that's involved, like a notary or something, that it will ensure the legitimacy of the contract, as well as enforcing any issues that may arise with the contract. And again, you're probably familiar with these types of contracts. Now on the blockchain, these are smart contracts, very similar to regular contracts. Just like regular contracts, you can program these smart contracts to require certain conditions and requirements to be met. The only thing with smart contracts is it eliminates the need for that third party. Everything that you write within the smart contract can be self-executing through the blockchain. And this unlocks the ability of a lot of things. One, including trustless exchanges, because now you have this peer-to-peer interaction without this middleman or this third-party character. You also have automated executions. So now when you program a smart contract to do something, once requirements are met, the contract will execute those agreements automatically without needing, again, a third party or anyone else as part of that transaction. As long as the requirements of the contract are met, the contract can self-execute itself. And now, because smart contracts are deployed and they are stored on a blockchain, they follow the same rules of the blockchain as well. Smart contracts are immutable once deployed because once that data has been stored on a block and on the blockchain, you can no longer change or edit the agreements that you have put into that smart contract. And throughout this course, we will be dealing with these smart contracts because, again, they allow us the ability to build this utility and application on top of EVM compatible blockchains like Ethereum. Now that we have a higher level understanding of what smart contracts are, let's dive a little deeper into some technical terms with smart contracts. The first part of a smart contract is its agreement. And these are going to be the conditions that you code the smart contract to do. Now, normally these smart contracts follow a if this then that type of agreement, meaning if this happens, do this. If this doesn't happen, do this, which is very similar to a lot of programming languages if you're used to it. You then have the signers of the contract, and these signers are represented by digital signatures. And these digital signatures can be authorized and signed by something called wallets, which we'll go over in the next section of this getting started. But all you need to know right now is that wallets are used to sign and execute these smart contracts on top of a blockchain. Do also remember that smart contracts, because on the blockchain, are fully transparent as well, meaning anyone can see and view a smart contract that is deployed to a blockchain. This allows for transparency and accountability because now anyone can go and view a smart contract that is deployed before using it and see if there's any malicious activity or anything on those smart contracts before actually interacting with it. In the space of blockchain development, you may also see smart contract auditors who do exactly this. They look through smart contracts, make sure everything is done correctly and there is no malicious activity that can be done with the smart contract, and they kind of get a stamp of approval. Now again, smart contracts are self-executing programs, and when we code these smart contracts to do something when certain conditions are met, they can trigger and execute these functions once these conditions are met. This can be transferring digital assets, this can be interacting or storing data to them. An example can be we can write a smart contract that says anytime I interact with this contract, I will transfer 10 digital tokens to person B. Now, one of the requirements could be that I have to actually own 10 digital tokens in order to execute this transaction. So if I only have 5 tokens and I execute this transaction, the smart contract won't magically transfer 10 tokens to person B unless I meet the requirement of actually owning 10 tokens before I can transfer it. But if I do own 10 tokens, the smart contract can then withdraw 10 tokens from my account and send 10 tokens over to person B. And now there is no third party that is actually taking my 10 tokens and giving it to person B. No one in the middle of this exchange is ever dealing with that. Instead, I can now transfer directly those 10 tokens to person B. And again, in the smart contract section of this course, we're going to take a much deeper dive into the components and what actually creates the structure of a smart contract. Right now, we're just going over a higher level view of what smart contracts are. But we just covered a lot of information about smart contracts, and just like the blockchain section, I'm going to provide a metaphor to help you visualize a little bit better on what smart contracts are and how they work. So in this metaphor, we'll think of a smart contract kind of like a vending machine. Vending machines normally have different food or drink items that you can select from. You provide it with the right amount of money that you need to be charged in order to purchase a certain item from that vending machine, and the vending machine gives you that item that you select. Much like a smart contract, you have predetermined rules on that vending machine that it needs to accept a certain amount of money depending on the item that you select, and then it will transfer you that item in return. And again, this is following a if this then that type of flow. So in the vending machine, we can say that is our smart contract, and we write down a few requirements. Let's just say drink items are $1 and food items are $1.50. We can program our vending machine to only give out a drink item if the person has deposited the right amount of money. In this case, they need to deposit $1 or more in order to purchase a drink item. But if they do not deposit $1 or more, we cannot provide them the drink. So in our vending machine, we check to see if someone has paid $1, and if they haven't, we can't give them the drink. But if they have, we can now dispense that drink out. There's no third party like a cashier or something when buying this drink. The vending machine itself self-executes this because we have programmed it with these predetermined conditions to provide a drink or food item to the customer depending if if they have paid the right amount. We can also take this a step further in the metaphor and say if someone purchases a food item, they need to, of course, deposit $1.50 or more. But if they deposit $2 or they deposit more than $1.50 and they select a food item, we will refund them the difference of $1.50 to the amount that they deposited. And that's how you get your change back if you spend more than what the actual item was. And again, just like a smart contract, we can program the vending machine to have these predetermined conditions, and it will self-execute this pending on the amount and the selection that the user has given. So I hope that metaphor gives you a better understanding about how smart contracts work. Of course, we'll still be taking a deeper dive again in that smart contract section, but the final thing I want to go over in this section is a little bit about the programming languages needed to create these smart contracts. And again, in this course, we will be covering blockchain development, especially on EVM compatible blockchains. And all these blockchains normally have smart contracts that are programmed in a language called Solidity. And Solidity, like many other programming languages, will deal with things that you're very familiar with, from constants, variables, functions, loops that you can implement into your smart contracts. I do want to mention this before we get into the actual smart contract and application section, and we'll mention it again there, but having a foundational understanding of programming and how to code will better help you understand exactly how to create smart contracts. This course will not be going over coding fundamentals, although you can still follow along. Just note that you may have to rewatch certain sections a few times to better understand the concepts that we are going over. But again, if you do want to learn a little bit more about Solidity before we start learning it in our smart contract section, you can always feel free to search that on your own and learn a little bit more. But again, I hope this section helped you a bit with the higher level understanding of what smart contracts are. And now you also have a little bit more knowledge on the programming language needed to create these smart contracts. In the next section, we're going to go over wallets and what they are. We're also going to create your very own wallet if you don't have one already. If you remember earlier in this section, we talked about digital signatures and being able to execute functions from our smart contracts. This requires something called a wallet. So in the next section, we'll be covering wallets, what they are, how they work, and we'll also be creating, again, your very own wallet that you can use throughout this course and that you can use for any of your blockchain activities. In this section, we'll be covering wallets and what they are and why they're so important to blockchain development. We'll also be creating your own wallet if you don't own one already, and you can use this wallet throughout this course along with your blockchain development journey, or if you just want to interact with Web3 applications in general. So many of you may already be familiar with a physical wallet. You use it to hold your cash, your debit and credit cards, maybe some ID and identification, or some reward cards as well. Wallets that we use to interact with the blockchain are very similar, where they can hold things like your digital currency, your digital assets, even digital assets that help identify certain things. Now, you may already be used to some sort of digital wallet as well. This could be something like a Google Pay, PayPal, Venmo, Cash App. These digital wallets allow you to hold a currency or balance and allow you to transfer them to one user to another, but it allows you to have your currency that you normally hold in your credit card or debit cards or cash inside of this digital app. Wallets that we'll be using on the blockchain are very similar, but instead we'll be interacting and transacting these exchanges on a blockchain instead. Some of the things we're going to be covering in this section about wallets are going to be your keys, which your wallet will have something called a private key and a public key. We'll also be going over how your wallet can interact with different blockchains and how you can send and receive digital assets from your wallet. So we'll first start off by talking about your keys. Again, your private key and your public key. When you create a wallet, you'll be given a private key for that wallet. Your public key is kind of the key that you use to verify transactions when interacting with the blockchain. And again, we'll kind of go over these private and public keys once we get into creating your very own wallet after this. Now, the very important thing you're going to have to know is that your private key must be kept secure. You'll probably hear us repeat it many times throughout this course, but your private key is very important to your wallet. Again, this private key gives access to the wallet and is something that you don't want to just give out or have anyone else gain access to, because with that private key, again, they gain access to the wallet. Now, we'll go over a couple types of wallets, and you may hear some of these terms when hearing more about wallets. The first one is going to be a software wallet or a hot wallet. This is going to be a wallet that is going to live on a web or a mobile device like an application, a browser extension. And these wallets may be the easiest to actually interact and do blockchain development with, and is what we'll actually be creating within this section. The other type of wallet that you might hear is a hardware wallet or a cold wallet. And these wallets are going to be physical device wallets that you can normally purchase. And instead of storing your digital assets on a software wallet like we just went over, you can store them on an actual physical wallet, something like a ledger, for example. Now, each of these wallets have pros and cons. These software or hot wallets do have the ease of use, being able to interact with blockchain applications because they are based on the browser or mobile device, but aren't going to be as secure as cold wallets, whereas cold wallets are very secure and require the physical device in order to interact with those wallets, but aren't very user-friendly when it comes to blockchain development or interacting with blockchain applications, because again, you do need to have that physical wallet on you in order to approve transactions. So we've covered a little bit about the wallets, but let's actually now create our very own wallet. So I'm going to jump on the computer here. You can follow along and create a wallet if you don't already have one. If you do, you can check out the timestamps down below, skip on over to the next section and continue on this course. But in this example here, we're going to be creating a wallet. We'll actually be creating a MetaMask wallet, which is one of the more popular wallets to use on the blockchain. And we'll take you step by step on how to create that right on your computer. So without wasting any time, let's jump on the computer and let's get started. So on my computer, I am on MetaMask website, which is metamask.io. We'll add this down in the description as well, so you can always reference down there. For any links to sites or documentations, we'll link them down below. But on MetaMask site, you can see here that this is a crypto wallet and gateway to blockchain apps. You can read a little bit more about it. This is, again, probably one of the more popular crypto wallets used especially for interacting with blockchain applications on the web. Now you can always head over to the download tab here and it'll show you the different devices that you can download MetaMask for. We are on the Brave browser here, but you can also see that it supports Firefox, Chrome, Edge, and Opera as well. And if we come back here, you'll see that it navigates you to download the proper extension for the browser that you're in. So if we click on that, it's actually going to install a Chrome extension onto our Brave browser here, but it'll bring you to the Chrome web store where you can add the MetaMask extension to your browser. So hit add to Brave here, we'll hit add extension. And once you add the extension, a new page should pop up. And here you can either import an existing wallet if you already have one, or you can create a new wallet, which is what we're going to do right now. So right here, it says, let's get started. We can agree to MetaMask terms of use, and we can create a new wallet. Right here, you'll see that MetaMask says, help us improve MetaMask. MetaMask would like to gather usage data to better understand how our users interact with MetaMask. This data will be used to provide the service, which includes improving the service based on your use. It'll show you what MetaMask will be doing, what they will never be doing. And of course, if you agree to this, you can hit agree. If not, you can hit no thanks. But in order to continue, you'll have to agree here. Now you're going to create a password to access your MetaMask wallet extension. You can create any password you want. You just have to put in your password here and then confirm it down at the bottom right over there. So I'm going to create a password really quick, and I have my password in there. I'll check off that I understand MetaMask cannot recover this password for me, and I will create a new wallet. Once you do that, you'll see this little video that goes over securing your wallet. I highly suggest watching this video. It talks about your secret recovery phase, which we're going to go over that in just a little bit. But that secret recovery phase is going to allow you to gain access back to your wallet if you ever need to gain access on another device, or if you just lose access on the device that you created it on. It'll explain a little bit about what your secret recovery phase is In this case, it's going to be a 12-word phrase, 12 different words in a specific order that you have to copy down, store on the side, somewhere secure. Again, very much like your private key, you don't want to just give this out to anyone. So once you read a little bit about that and you watch that video, we'll hit secure my wallet, and you'll see here, it'll say write down your secret recovery phase. They're going to show you a 12-word secret recovery phase, and we can save this into a password manager, store it in a safe deposit, write it down, and store it in multiple secret places. So what you'll do is reveal your 12-word secret recovery phase, write that down, store it. Once you're done, we'll be able to continue to the next section. Now, you do want to make sure that you write down these 12 words. You are going to have to verify them in the next step. So don't think that just not copying them down and skipping on over to the next step is going to be the smart idea to do. Again, this is a very important phrase, and you're going to want to write this down and keep it safe. So you can see here that they are going to have you confirm your recovery phase and give you some empty slots where you'll have to fill in the words that were in the previous section. So I'm going to fill this out and I'm going to hit confirm once I am done. And once you are done confirming that, you'll see wallet creation was successful. Again, it gives you a reminder that it cannot recover your secret recovery phase and just how important that secret recovery phase is. You'll probably hear us repeating a lot of things within this course, but just remember, we're repeating it because it's very important, and you should not share your recovery phase with anyone because it does give them access to your wallet. So once this is done, we'll hit got it. It'll now say your MetaMask install is complete, and we can pin this in our browser extensions if we choose to do so. It just shows us how to do that right over here, but we'll hit the done. And right now we have our wallet opened up in our web browser here in one of our tabs. You can see at the very top, we have our MetaMask logo. We have our account right over here. So we can actually have multiple accounts within this MetaMask account. And we're going to go over that in just a bit. Over here to the left, you'll see we have Ethereum mainnet. This is the actual network or blockchain we are currently connected to. We can select that and we can add different networks and select the different networks that we want to connect to. Right below our account, there is, you can see this number or your wallet address. It starts with a 0x and is then followed by some numbers and letters. And this is your unique identifier or your wallet address. This is your wallet's identity. So instead of showing proof of identity that you are the owner of this wallet, when you sign and interact with things on the blockchain, this wallet address is your identity. So kind of going back to the anonymity that we were talking about in the previous section, again, you don't need to provide your name and information when dealing with the blockchain. This wallet address here is kind of like your username or identifier when interacting with it. We can view our funds right over here. You can see I don't have any funds here because this is a brand new wallet, but we will be going over how to get some funds into your wallet because we will need it in order to start developing smart contracts and our applications. Right below that, you have your buy, send, swap, bridge, and your overall portfolio. So buying if you want to buy some funds, send if you want to send funds to another wallet address, swap if you want to swap your funds for other funds. You can swap your tokens for other tokens. Bridging, we're not going to cover that in too much depth. Just know that you can bridge or transfer funds from one blockchain to another. And portfolio gives you kind of a full overlook of the portfolio of assets that you have within your wallet. We'll take a step down below that. We have tokens. So it'll show you your list of tokens and different tokens you have within your wallet. We have NFTs where it'll actually show some of the NFT tokens that you have within your wallet as well. And then activity, it'll show you recent transactions that have happened through your wallet. Now we're going to come back up to the top right here, and we have this ellipses here that we can click on. And if we go to settings here, this is your settings for your MetaMask wallet. Now we're not going to cover everything in here, but we are going to come down to this advanced tab here, and we're going to scroll down just a bit until we see show test networks. Now test networks are going to be like the name says, they're going to be networks that we can use for testing and developing. So we have what's called test nets and we have mainnets. And mainnets are going to be the actual main blockchain where you're going to actually be using actual digital currency with value in order to interact with it. Test nets are going to be more so for development because we can get free testnet funds and we can develop and test things on top of these testnet blockchains before we actually deploy them onto mainnet. And again, these funds are free to get. There's no value or anything in the digital currencies on testnet because again, this is for development purposes. And just like how we explained in the previous section, it's important for us to test and develop on these testnets before going to mainnet because when we deploy something to a blockchain, it is immutable and we can't really change the information that we deploy. We want to make sure everything is good and tested out first before actually deploying something to a mainnet blockchain. I'm going to toggle this on here, and if we head back to and close out our settings here, if we come to our network here where it says Ethereum, and if I click on that, you'll now see we get a little bit more networks that are added into our list of networks here. We only had Ethereum and Linea. Now we have Gurley, which is the testnet for Ethereum. Sepolia, which is also a testnet on Ethereum, and then we have Linea Gurley, which is Linea's testnet. I'll close that. Now we'll come back to this account section here, and again I'll click on this, and just like I mentioned earlier, you can have multiple accounts within this MetaMask account. Right now we only have one account, but down here we can either import accounts if we have one. We can actually import a hard wallet account into our MetaMask, but I can also hit add account. So we'll hit add account. We'll call this dev account, and this will be the account that we use for development purposes. We'll hit create, and you can see here that we now have a dev account. If I click on that, I can switch between the dev account and the account one. If I click on that, you can see that they both have two different wallet addresses because they are two separate wallets. They are just under this one MetaMask account. Now, if I come to wallet one here and I hit this ellipses option on the top right, I can look at account details. Now, in account details, you can view your private key for that wallet. Now, again, the private key is very important. Just like your 12-word secret recovery phase, you don't want to share this with anyone because this does give them access to the wallet. But if you ever do need your private key, which in some cases you may need for development purposes in order to access your wallet and sign transactions, you can always find it within the options that we just went over. So again, the private key, each wallet is going to have its own private key. So account one is going to have a different private key from this dev account here. If someone does get a hold of that private key, they have only access to those individual accounts. Now that 12-word secret recovery phase, if someone gets a hold of that recovery phase, they have access to your whole MetaMask account, which includes all of the wallets within it. So again, you don't want to just give anyone your 12-word phase or your private keys. But we can come up to the top here as well. If we hit that options and go to account details, you can also rename your accounts up here. So we'll call this one test account. Hit that little check mark. So we have test account and we have our dev account here. Now what we're going to go over next is how to add different blockchain networks to your wallet so that you can connect to them, and how to receive some free testnet funds so that we can interact with blockchain applications, and we have some funds that we can use as we go on throughout this course. Now back on my computer here, we're still in our MetaMask wallet, and what we're going to do first is add a new network that we're going to connect to and pretty much use throughout this tutorial. Again, we're going to be using testnets, and that is just because we can get some free currency on them in order to start interacting and developing on them. Now in my MetaMask wallet, I'm going to come to the drop down of the networks here that I have set to Ethereum right now. And once I click that drop down, we'll have the option at the bottom here to add a network. Now this is going to give us the ability to search the main networks that are available to us. You can see down here there are some popular ones that we have here, but you can see that we have a few here. So we can actually add Polygon. You can see here that it's going to add this network to our wallet. We can hit approve. Once it's added, it's going to ask us if we want to switch. We're not going to switch right now. But if we come back to the drop down here, you can now see that the Polygon mainnet is added on. Now we're also going to go and add Polygon's testnet, which is actually called Mumbai. And if we come back here and go to add networks and I try to add and look up Mumbai, it's not going to pull anything up because it's going to mainly pull the mainnet, the blockchains here, not the testnet ones. So what we're going to do is actually add a network manually. So if we come here and add manually, we're going to have to add in our Mumbai testnet. We can actually call that here. So we'll call it Mumbai. But we're going to have to fill out this information here. Now, we can get this information if we come on over to ThirdWeb's website and we come over to our chain list tool. We'll drop the link down in the description below if you need to reference it. But it is thirdweb.com/chainlist. Once you're on the chain list tool here, you'll see a search bar up here. You can just type in Mumbai and you'll see here that we have the Mumbai chain. So if we select that, it'll give us the information about the Mumbai blockchain, but it'll give us things like the RPC, the chain ID, and the native token, which is what we need to fill out with this information here to add our network. So we'll get the RPC URL. We'll copy this right over here, come back to our MetaMask, paste that in, come over to chain ID. We'll copy this chain ID right here. Come back to MetaMask, paste that in, and then we can also put in the currency symbol as well, which is Matic. Paste that in. Block Explorer is optional, but if you come back here, you can see here that this is the Block Explorer URL if you want to add that in, but it is optional when adding in a network manually. Once we have all of that, we can hit save. And you can see that it has been successfully added, and we can switch over to our Mumbai network. So now we are connected to our Mumbai network and we don't have any Matic. But again, because this is a testnet, we can now go to something called a faucet. So many of these blockchains will have something called a faucet where you can receive free testnet funds and deposit it into your wallet. So we're going to come over to Polygon's faucet. Remember, Mumbai is a testnet for the Polygon blockchain. We'll add this link down in the description as well, and you can receive some of your own testnet funds too. But on here, we're going to be choosing the Mumbai network. We're going to select the Matic token, and we just need to paste in our wallet address right over here. So you can come back to your MetaMask wallet, or if you have the extension, you can open up that little extension. We'll just skip through this. And up here, you can just click on that to copy your wallet address. Come back in here, paste that, and submit. You can see that you're going to get 0.2 Matic and it's going to be transferred to our wallet, and we can hit confirm. You'll see that the request is put through and the transfer is on its way. It says that the tokens will be transferred to you in 1 to 2 minutes. So we can actually just come back to our MetaMask tab here. We'll wait a bit for the Matic to come through, but then we should see that we will have 0.2 Matic within our account. All right, and there you have it. We now have 0.2 Matic within our dev account. Now you can also come back to the faucet here. You can see that this address has already received test tokens, but we can also send tokens to our test account. So if we come here and we switch back to our test account, we can copy the wallet address of our test account. And then we can come back here, select Matic, and paste in our test account. And we can also send 0.2 Matic to that account as well. So I'm going to send 0.2 Matic there. We'll confirm, go through the same process again. If I come back to my MetaMask tab, we'll wait until that 0.2 Matic shows up here. And there you have it. We now have 0.2 Matic in our test account. So if I go from my test account to my dev account, you can see both accounts now have 0.2 Matic. And we have some testnet funds that we can now start using to deploy our smart contracts, interacting with the blockchain. And we can now start using these wallets. Now, just to get you familiar with using wallets, in case you're new to them and this is your first wallet, what we're going to do is do our first transaction using our wallet. What we're going to do is send some Matic from one account to our other account. So what I'm going to do here is come over to my dev account and I'm going to copy the wallet address here. I'm then going to come back to my test account, and right under here you can see we have the send button. So what we can do is send some of this Matic to another account that we choose. So I'm going to hit send. You can select any of the accounts that you have. So if you're just transferring between the wallet accounts that you have, it'll show you a list here and you can select those accounts. But in case you are transferring this to another wallet address or account, you can scan their QR code or you can paste in their full wallet address up here. So I just pasted in the dev account wallet address. You can see the asset that we have chosen is Matic. We have 0.2 Matic available within this account. So then we can select how much Matic we want to send over. I'm going to put 0.05 Matic, and that's how much Matic we're going to send from our test account to our dev account. Now below here, you're going to see something called a gas. Now, if you remember when we were talking about gas within our blockchain section, this is kind of like a transaction fee that we need to pay in order to execute this transfer. Anytime you interact or need to change data or information on top of the blockchain, you're going to be charged this gas fee. And you can see here, it gives us an estimated value of what that gas fee is going to be, which is 0.0000315. And it'll give us an estimated time of how long this transaction is likely going to take. Now, do keep in mind this gas fee is going to be charged to the account that is doing the transaction. So in this case, our test account is the one that is going to be submitting this transaction to send Matic to our dev account. What does this mean? This means that I can't send 0.2 Matic. Because if I try to send the full 0.2 Matic, you can see if I hit the max here, I'm not going to have enough Matic within my wallet to cover the gas fee, right? Because I also need to pay the gas fee plus on top of the 0.2 Matic that I am trying to send. So that's why when you hit max here, it's never going to be the full amount that you have within your wallet. It's going to be something less because you do have to cover those fees in gas. I'm going to change this back to 0.05. And we'll hit next. You'll see here a confirmation page. It's saying we're going to be sending Matic 0.05. We're sending it from our test account to our dev account. You'll see here we have the gas with the estimated gas total here, or gas fees. And then it has the total estimation here, which is the total amount that we're sending over plus the gas fees. And if that is something that we are okay with, we can confirm. You'll now see in the activity tab that we have this new transaction here that is queued, which is a sending transaction. It's currently pending. It's going through this transaction. Everything is being written now to the blockchain. And once this is done, we'll see that the send has been completed. There you go. You can see that we now have this green date here, which is showing that this transaction has been successfully completed. If we take a look at the balance of our test account, we are at 0.15 Matic. And if we take a look at our dev account, we now have 0.25 Matic. And you can also see now on our dev account, in our activities, we have a receive here because we received 0.05 Matic. And just like that, you have now created your very own crypto wallet. We received some testnet funds and we performed our first transaction on the blockchain. Now, with everything that we've gone over in this course so far, from learning and understanding Web3, blockchain, smart contracts, to creating your very own crypto wallet and getting your own digital assets, you have now the fundamental knowledge to start using blockchain technology and start interacting with Web3 applications on the blockchain. Now, from this point forward, we will start to learn a bit more about how to become a blockchain developer and learning the actual skills and knowledge it takes to start building applications and smart contracts on the blockchain. We do have one more section to go through in getting started, and that's to go over a tool called ThirdWeb. Now, ThirdWeb is a powerful framework that allows you to build, launch, and manage Web3 or blockchain applications easily. We'll do a real quick overview of ThirdWeb so you have a better understanding of its tools and what it has to offer, and then we'll jump into actually using ThirdWeb to deploy our very own smart contracts. In this section, we're going to be covering a Web3 development tool called ThirdWeb. And ThirdWeb is a development framework which allows you to seamlessly build, launch, and manage your Web3 applications and games all across any EVM compatible blockchain. A quick overview of what we're going to do in this section is cover really what ThirdWeb is and some of the tools it has to offer. And these tools that we go over, we will be using some of them within this course as we build out blockchain applications for the web. But ThirdWeb also offers the building tools if you're looking to build blockchain or Web3 games or even mobile applications. But what we'll do next is actually jump onto ThirdWeb's website here. We'll take a quick look of the overview of what ThirdWeb is as a tool, and we'll also show you how to navigate around some of the documentation in case you want to read a little bit more on some of the other tools that ThirdWeb has to offer. So on my computer here, you can see I have thirdweb.com open and we are on our homepage here. And you can see here ThirdWeb is the fastest way to build Web3 apps. And we have a bunch of SDKs in multiple languages and the ability to deploy things like smart contracts. We have different tools and we have different infrastructures that you can use for Web3 development. Now you can go straight onto the dashboard, which is what we're going to be using in our next sections of this course to deploy smart contracts and manage our smart contracts. But we're not going to get into that here in this video. We're just going to do again an overview of ThirdWeb as a tool. So if we scroll down here, you can see ThirdWeb is an all-in-one solution. We have multiple dev tools and multiple infrastructure tools. Some of the tools that we have are things like the Solidity SDK, which allows us to create smart contracts. Explore, which allows us to actually deploy some pre-built smart contracts that we have. We have SDKs. This goes for React Native for mobile, Unity for games. We have pre-built UI components, and we take the complexity out of things like connecting a wallet or creating a button that interacts with a smart contract. We also have the ability to deploy and publish smart contracts, and we have a nice dashboard that you can use online to again manage all your smart contracts in one place. We also offer a bunch of infrastructure tools from data feeds, gasless transactions, fiat on-ramping, storage, RPCs, wallets, and auth. And you can see here we support any EVM compatible blockchain, and you can use our tools to build out applications, games, and mobile apps. Now a quick sample here you can see of how ThirdWeb makes things so easy. Normally, if we scroll all the way here, if you are building a Web3 application without ThirdWeb's tools and you needed to, connect your smart contract to your applications, and you needed to maybe retrieve some of the information from it, you would have to go through all this code here of setting up things like your provider. You need to get your contract ABI, which is something that we'll learn a little bit more about later. We would have to then get your contract, find the owner of all these different things that you would need to do. And you can see here that's about 88 lines of code versus ThirdWeb. And you can see here with just 7 lines of code, we can obtain the same thing. So again, ThirdWeb is a tool and framework built to make building Web3 applications and blockchain applications super easy. Also with ThirdWeb, we are open sourced. All of your apps and contracts are also owned by you, and you have no vendor lock-in. So if you need to configure things a certain way or, fine-tune things to your liking, you have full control over that. Again, you can build things from smart contracts, apps, games. We're actually going to take a quick look at our documentation after this, and we'll show you how you can navigate through a little bit of the documentation to find out information that you need if you're looking to build these. Again, we support multiple languages from JavaScript, React Native, Python, Go, and Unity. And you can deploy any of your smart contracts onto any EVM compatible blockchain. Another useful thing that ThirdWeb provides is the use of their dashboard, which is a nice UI that you can use to kind of manage and maintain your smart contracts when you deploy them. And as you can see here, it also allows you to collaborate with team members, and you can manage permissions, and everyone can take a look at your smart contract through the dashboard. And the amazing thing too is ThirdWeb is completely free to use. There are no hidden fees. Right now, you can deploy and build your very own blockchain applications completely for free. The only things you're going to have to pay for are any of the transaction or gas fees that you need to actually pay for when deploying smart contracts. But we'll get into that in the next section when we actually deploy a few of our own. So the next thing we'll take a look at with Third Web is the documentation. Now, you can head up to the top navigation here and just go to docs, or you can go to portal.thirdweb.com and we'll drop that link down in the description as well. But here you can see that Third Web offers a bunch of tools. Again, it really is a complete solution when building a Web3 application. And when you come to the documentation here, it can be a bit overwhelming, but I'm going to walk through some of the things and give a quick explanation of everything so it's a bit easier to understand. We'll also go through some of the tooling that we're going to actually be using within this course, and our main focus will be some basic smart contract or Solidity development, and we'll also be building web applications. So on the left navigation here, you can see all of our different tools. Solidity SDK is going to be our tool or SDK that we use when developing and creating our very own smart contracts. Again, Solidity is the programming language we use when building smart contracts on any EVM compatible blockchain. The Explorer is something that we will actually cover shortly in the next section, which is going to showcase some pre-built smart contracts by Third Web and some featured contracts from other protocols as well. And in the Explorer, you can actually deploy these pre-built smart contracts with one button. So this is things from like your own cryptocurrency token to your own NFT contract. And we'll kind of go over the different types of contracts as well. Our EVM SDK, this is actually what we're going to be using when we build out our very own applications. This SDK here allows us to interact with any EVM compatible smart contracts. So when we build out our web applications, we'll actually be using this EVM SDK. We also do support Solana. So we have a Solana SDK here as well. We have our UI components, which are some UI components that we have built out for you already. This includes things like a button to connect a wallet to your application, or a button that interacts directly with your smart contracts. We have the ability to deploy and publish smart contracts, which will go into deeper detail in the next section when we actually deploy and publish our very own smart contracts. Again, we have that dashboard, which is a nice UI that you can use to manage and maintain your very own smart contracts. And we have our CLI or command line interface here, which allows us to use our command line to deploy and create our applications. So if you want to read a little bit more about our tools, you can go through the documentation. We're actually going to be referencing a lot of this documentation as we go on through the next sections when we deploy our very own smart contracts and build out our own applications. You can see right here to the right in this getting started section, these are the different languages that we can use. We support React, React Native, TypeScript, Python, Go, Unity, and Solidity. In this course, we're going to be using mainly the React and Solidity. Solidity to, again, create our smart contracts, and we're going to be using React to build out our web applications. And that will really cover the things that we're going to be using from Third Web within this course. Again, in the following sections, we'll be taking deeper dives so we better understand how to use these tools. But a quick look through Third Web's documentation so you know where to look for this information, or if you want to search for some information on your own, you know where to look. And again, Third Web has much more to offer. If you scroll down here even more, again, we do have infrastructure tools that you can use as well. And we have a bunch of other solutions from mobile and gaming. So again, you can create games with Unity, and you can also develop Web3 mobile applications using React Native. Down at the very bottom, we also have additional resources on top of our docs. This includes guides if you want step-by-step written guides that you want to follow. We also have templates that you can clone from our GitHub repository, and you can take a look at those templates and build out your own applications. We also have a YouTube channel where we post a bunch of tutorials if you want to watch a visual step-by-step guide or tutorial on how to build certain Web3 applications. We have that as well. And another important part is going to be our Discord channel. If you need any support or you have any questions about using Third Web, join our Discord channel. You can drop a ticket in our support channel, and our support team is happy to help you out or answer any of the questions that you may have. So there you have it. That was a quick overview of what Third Web is as a development tool, what we're going to be using from Third Web within this course, and kind of the bigger picture of what you can actually create using Third Web. With all of that being said, this does it for our getting started section of this course. We went through a lot of information, and I hope this gave you a better understanding of the concepts of what are Web3, what is blockchain. You also learned what are smart contracts and created your very own crypto wallet. And you've been introduced again to an amazing blockchain development tool by ThirdWeb. And with that, in the next section, we're actually going to start our blockchain development journey and start understanding a little bit more about smart contracts. We're first going to take a look at ThirdWeb's tools and our Explore page and deploy some pre-built smart contracts that we're going to use within our application. We'll go over the different types of pre-built smart contracts that we have, some terminology when it comes to smart contract standards, and by the end of the next section of this course, you'll actually create your very own custom smart contract, learn how to deploy it, and we'll prepare all of our smart contracts to then build our very own blockchain application. So let everything that you just learned soak in, get ready, and let's head on over to the next section. Hey everyone, and welcome to the smart contract section of this course. Now, we covered smart contracts a little bit in our getting started section, but this section is purely focused on learning more about smart contracts and their importance and how they can build out applications on the blockchain. So a quick overview of what we're going to be covering in this section. We're first going to learn a little bit more about smart contract standards and go over some of the more popular standards like ERC20, ERC721, and ERC1155. These are going to be your smart contract standards for cryptocurrencies and NFTs. Then we'll take a look at ThirdWeb's Explore page, which is a collection of pre-built smart contracts that will actually allow you to deploy these popular smart contract standards with a single click. You're not going to need very technical knowledge in order to create your very own cryptocurrency or NFTs. With the Explore page, you can again deploy these contracts with a single button. And with that, we'll deploy our very own ERC20, which is a digital currency, and we'll deploy our very own ERC721 and ERC1155 NFTs through the Explore page. Once we have all of our contracts deployed, we'll take a deep dive into ThirdWeb's contract dashboard. These dashboards make it easy to manage and maintain your smart contracts, from viewing events to calling functions to looking at specific details and editing preferences on your smart contract. Smart contracts can be pretty intimidating at first glance, but the ThirdWeb dashboard makes it very easy to understand and simplifies the process. Once we deployed a few of our own smart contracts, we'll then take a look at creating some of our own from scratch. We'll create a handful of basic smart contracts and start to learn the basics of Solidity and how smart contracts work to how they are built. And after we create some of our own custom smart contracts, we'll then learn how to deploy those smart contracts using ThirdWeb, and we'll cover something called Publish, which allows you to share your smart contracts and allow others to deploy them with one click, just like you would through the ThirdWeb Explore page. Again, this is a lot to cover in this section, and we have timestamps down in the description to help you navigate. Go back and rewatch steps if you need to cover them again, or you can skip ahead if you want to get to specific parts of the video. Again, by the end of this, you'll have your very own digital currency and NFT smart contract and your very own custom smart contract that you built. So without wasting any time, let's jump onto the next section, learn a little bit more about these smart contract standards, and get started building our very own. Hey everyone, and welcome to the next section. In this section, we're going to start learning a little bit more about smart contracts, covering the standards, deploying our own, and using ThirdWeb to help us along the way. Now, I do want to preface before we start that this section will be easy to follow along for anyone. We'll actually be deploying our very own smart contracts and interacting with them without touching any lines of code. Now, later on in this section, we do learn a little bit more about how to customize and create our own smart contracts, where you will need a little bit of coding knowledge to follow along. But again, in this first part, you'll be able to deploy your very own digital currency and NFT with no coding knowledge needed. So a quick overview of what we're going to be covering in this section here. We're first going to cover some of the popular smart contract standards, which include ERC20, ERC721, and ERC1155. We'll go over the differences between them and how you would choose which standard you want to use depending on the project you want to create or the smart contract you're looking to deploy. We'll then take a look at ThirdWeb's Explorer page and look at the pre-built contracts ThirdWeb has to offer and how we can actually deploy our very own versions of those smart contract standards with a click of a button. Then once we have those smart contracts deployed, we'll take a look at ThirdWeb's dashboard, which makes it easy to manage and maintain your smart contracts all from one place. Again, smart contracts can be intimidating at times, and the ThirdWeb dashboard makes it very easy to interact and manage those smart contracts. So we'll go through some of the features and see what the dashboard has to offer. And again, by the end of this section, you'll have your very own digital currency and NFT smart contracts that you can show to others. So with that being said, without wasting any time, let's jump on the computer and learn a little bit more about these smart contract standards. On my computer here, I am on ThirdWeb's documentations here, and we are in the section of choosing the right pre-built smart contract, where it kind of goes over the different types of smart contracts and why you would choose one over the other depending on the project you're looking to release. Now we'll add again all the links to these documentations that we pulled down in the description below. So if you want to reference them yourself, you can check out the description, and under this section, you can find the links that we are referencing. But right over here, we're going to go over again 3 of the main types of smart contract standards that you'll probably see the most of, which is ERC20, ERC721, and ERC1155. Over here, you're going to see a bunch of different smart contracts that we have that you can deploy based on the standard that you're looking to deploy. But we're not going to get into that right now. We're just going to cover the differences between those 3. Now, we also do have a YouTube video here that you can reference and watch if you want to learn a little bit more. An ERC20 token, you can think of it as your digital currency or cryptocurrency token. It is your standard interface for fungible tokens. You're creating this token that can be created, destroyed, and transferred to one another. You're basically creating a digital currency. And a lot of times these ERC20 tokens will be used for just that. They are used to create digital currencies or cryptocurrencies, and you can create these tokens, distribute them, and people can use those tokens to purchase other things, trade them as they like. So again, you can use them like a currency. People have also used them for point systems in something like a loyalty program, which when you look at it is just like a digital currency that you are spending. So again, your ERC20 tokens are for your fungible tokens. Now, the next standard that we're going to cover is something called ERC721. And ERC721 is going to be your standard for your NFT contracts. Now, NFTs stand for non-fungible tokens. And what this allows you to do is for your ERC721 smart contracts, you can create these NFTs, which each token that is generated from the smart contract is its own unique token. Unlike an ERC20 where each token generated is the same type of token, an ERC721, each token that is created from the smart contract is its own unique version. And ERC721 was probably the most popular standard utilized during the craze of NFTs. People would create these PFPs or profile pictures, and each one of them was a unique NFT or a unique token. This is probably, again, the standard that you see across the board and that most projects will use when creating those types of NFTs. Each one of those tokens, again, are a one-of-one token within that smart contract. Then we have our third standard, which is our ERC1155. And this standard kind of combined the standards of ERC20 and ERC721. You can look at ERC1155 as semi-fungible tokens. And what this means is similar to how ERC721 allowed you to create these one-of-one tokens. Within ERC1155, you can create different tokens within your smart contract, but each one of those tokens, you can have multiple quantities of it. So a lot of times what people will use this contract for are projects if you need to create something but have multiple versions of it. So unlike ERC721 where you could create one-of-one works of art and each one of those there would only be one that exists. With an ERC 1155, you could create art pieces, but you could have multiple copies of that art piece. So instead of having just one, you can specify if you want 50 or 100, or if you want even more. So again, ERC 1155 was your semi-fungible tokens. Again, a combination of what ERC 721 and ERC 20s were. And that covers the most popular smart contract standards. Again, ERC 20 is your fungible tokens, ERC 721 being your non-fungible tokens, and then ERC 1155 being your semi-fungible tokens. And again, there are many use cases for them, and you can get creative on how those smart contracts work together with one another when building out your own projects. Now, again, coming back to choosing your right contract here, now that you have a better understanding of those different contracts, we can look at the available pre-built contracts that ThirdWeb has to offer. You can see here we have a bunch of different contracts for all those different standards, from ERC 20s, ERC 721s, and ERC 1155s. And we can read a little bit more about those pre-built contracts that we have here. But what we're actually going to do is head on over to ThirdWeb's Explore page and take a look at these contracts a little bit more and start to see what we can actually create and deploy through ThirdWeb without having to actually write a line of code. So right over here, I am on ThirdWeb's Explore page. Again, this will be linked down in the description below. But this Explore page is a place for Web3 developers to explore smart contracts from world-class Web3 protocols and engineers. So a lot of these pre-built contracts are going to be created by ThirdWeb themselves. And we have a bunch of them here. You can see down in the bottom left, it'll say who the creator of those contracts are. And all of the contracts that we have in the Explore page are audited as well, meaning that a company has gone through for us, audited, and checked to make sure that these smart contracts are reliable. Now, you may also see some other contracts here that aren't by ThirdWeb, but are by other protocols. So we have something like Unlock Protocol, which you can create a membership smart contract. We also have one from doubledev.eth, which is for a new standard called ERC 4907, which is actually rentable NFTs. So you can actually create rentable NFTs that expires on a certain date that you set it at. So again, we have a bunch of different smart contracts here. All of these you can deploy with a click of a button, and you can go through, read a little bit more about these smart contracts, and you can actually take a deep dive and look to exactly what the smart contracts are for each of these. So what we're going to do is we're going to, again, deploy one of each smart contract. We're going to deploy an ERC 20, an ERC 721, and an ERC 1155. We're first going to start off with an ERC 20. Now, just coming back to the docs really quick here, if we look at these pre-built contracts and we look for ERC 20, we have two different types of ERC 20 contracts. We have token and we have token drop. Now, there is a difference between drop contracts and non-drop contracts. With our pre-built contracts, drop contracts are claimable by others. This means that they can be claimed or minted by other people for a certain cost. But for non-drop contracts, when a token is created, it is owned by the owner. So if it's your contract and you create a token, you will be the owner of that token. Now, there are, again, pros and cons, and depending on the project that you are using this for, will depend on if you need a drop contract or not. So if we look here on the Explore page, up here in the popular section, you'll see token. And if we click on this token here, that was one of our ERC 20 standards. You can see right over here, it says ERC 20 standard. And this, again, is a smart contract that will create a cryptocurrency for us. But this cryptocurrency is not going to be claimable by others. And just a quick example of that, that means if I create this contract, I can then initially create maybe 1 million tokens, but all 1 million tokens will be owned by me. Whereas if I did a token drop contract, I could specify that would be 1 million tokens, but I can give the option for other people to claim those 1 million tokens. And once those 1 million tokens are claimed, no tokens can be claimed after that. So again, you're either allowing the ability for others to claim it with a drop contract, or not, and everything will be owned by you with a token contract. So you can deploy a token contract here, or if you're looking for a token drop contract, if you scroll down, we do have a drops section, and this will have all of our different drop contracts from an ERC20, 721, and 1155. But for this tutorial and course, we're going to deploy a token contract. So we're going to come back up here to select the token contract. Now this here is a published contract, and we're going to cover that a little bit later on in this course. But these contracts are deployable by anyone. You can see here in the top right, there is a deploy button. We just need to click that deploy button and go through the transaction. And just like that, we would have deployed our very own cryptocurrency smart contract. You can read a little bit more about the contracts here. And we also have resources to the technical design doc, a full reference of it, and you can learn a little bit more in our documentations. On the right here, you can see who the contract was published by. So when you publish a contract here, it'll actually show your information here. You can think of it as a way to share your work or your contracts with others. You can view all the contracts from that profile as well. But we'll cover that a little bit later on in this section. Down here, you have details. So you have the published date. You can see the full audit report here as well. At the very top next to deploy, there's also this drop down. So the cool thing with published is you can publish versions of your contract. So if you improve it or you make upgrades to your contract, you can upgrade them, and people still have the ability to look at previous versions of your contract as well. So if you want to maybe deploy a previous version that doesn't have a function or had a function that worked a way that you wanted it to, you can deploy those versions, those older versions here. We're going to keep it at latest though. And if we scroll down here, you'll then see this window here. We have our functions. So you can take a look at some of the functions that the contract has to offer. So we can read a little bit more. So you can see here, we can click a function. We can read a little bit more about what the function does, as well as the inputs or the parameters of the function and what it requires. So those are write functions. We also have read functions, so we can see the data and information from our smart contract. So again, you can view all of the functionality of the smart contract right here within this window and tab. You have events. So again, we're going to learn a lot about these functions and events as we go on and learn a little bit more about our smart contracts and actually create our own. But events are going to be like notifications that get stored on the blockchain when a certain function or event in this case is called on top of your smart contract. Next to that, we have your code. So the code here is how we can get started using and implementing this smart contract into our very own applications. So if you wanted to build an application using JavaScript, React Native, Python, Go, or Unity, you can select the language that you're using, and it'll give you some code snippets on how to get started and interacting with this smart contract. So up here at the top, this is how you are going to initialize the SDK or third web SDK to start using the smart contract. And down here, you can see different functionalities for maybe getting your token allowance. If you click on that, it'll actually show you the code snippet that you can copy and paste into your project in order to get token allowances. So all of this here, again, you can just click the drop down menu of what you're looking to do, and you get a little code snippet of it. Back up here in sources, if we click on sources, this is going to be all of these source files for this smart contract. So you can take a look at all the different source files and what the code is that actually makes up this smart contract. So you can go through all of these if you choose to do so. You can just toggle down and you can see here all of the source code for the smart contract. So that was a quick overview of what the published contracts look like and a quick overview of the Explore page. So again, what we're going to do here is deploy our very own token or ERC20 smart contract. So coming back up to the top right here, we're going to hit the deploy now, and we're going to have to enter the contract parameters. So this is going to be things like the name of the contract. So we'll just call this third web token. We'll then create a symbol for it. So a symbol is going to be kind of like the ticker symbol for the token here. We'll call this TW token. We can add an image. So if you choose to add an image for your contract, you can do that here. You can add a description. So we'll just say this is an ERC20 token smart contract. Below that, we have our primary sale recipient. So this is if we were having an initial sell or selling these tokens. This wallet address, if you remember from our MetaMask, this wallet address is where the funds and fees would be sent to. Down here, we have our network and chain. Now with ThirdWeb, you can deploy to any EVM compatible blockchain, and all you need to do is select the drop down here, and then you can select the blockchain that you want to deploy it on. Now, if you followed us in the Getting Started section, we actually got some testnet funds. So testnets are test blockchains for developers, or if you just want to test certain things out, you can get testnet funds, which is basically fake digital funds that allow you to test out your smart contracts on top of a blockchain without actually using real money. And that's a way to test it before going to mainnet, which again will require actual funds. So we're going to be using Mumbai here, which is Polygon's, which is a blockchain, is their testnet blockchain. So we're going to select Mumbai here. If you select it and you don't have Mumbai set up in your wallet, it's going to actually allow us to add this directly to our MetaMask wallet. So you can see allow this site to add a network. We're going to hit approve, and then we're going to switch over from our mainnet here to the Mumbai network. So once we have that connected, you can see here we're connected to the Mumbai network, and we now have the option to deploy our smart contract. So I'm just going to hit deploy now. You can see we have our deploy status here. We're deploying our smart contract. So you're going to get a transaction that pops up in your MetaMask wallet. And you're going to see here, again, you're going to have to pay these gas fees. We covered gas fees in the Getting Started, but anytime you interact and need to write the data to the blockchain, we need to pay this gas fee. So this is the fee that we're going to pay. We're going to hit confirm to confirm this transaction. Our contract is now deploying to the Mumbai, so Polygon's testnet blockchain. And once it has been deployed, we're going to get a second prompt here, which is going to be a signature that we need to sign. And what this is going to do is import our smart contract that we deployed into ThirdWeb's dashboard. And this is going to allow us to start interacting and, again, managing this smart contract. So you're going to get a second pop-up here in your wallet asking for a signature request. You can just scroll down to the bottom and sign that. And this is again going to import it into the ThirdWeb dashboard, allowing us to see our contract dashboard. And once that has completely finished, you see here that you get navigated to your dashboard. Now, we're not going to go through the dashboard yet. We're going to deploy a few more smart contracts first, and then we're going to take a look at the dashboard in all, just because there are some differences between the dashboard depending on the smart contract standard that you deploy. So we just deployed our very own ERC20 standard smart contract, which is a cryptocurrency smart contract. So with a click of a button and, well, a click of a few buttons and confirming a transaction in your wallet, you're able to create your very own cryptocurrency. Again, no lines of code or anything. You can use those pre-built contracts from ThirdWeb, and you now have a cryptocurrency that you just created. I'm going to open up the home tab here in a new tab. And we're going to come over to browse contracts here. And what we're going to do now is deploy our next smart contract, which is going to be an ERC721 NFT smart contract. And if we come back to, again, choosing the right smart contract, we're going to look at that list again. And if we look at the standards, we have quite a few ERC721 smart contracts. If we start from the top here, we have a signature drop, which is an ERC721A contract. A is just a different iteration and version of an ERC721 contract that gas optimized NFT dropped. And there's an optional signature based minting. We're not going to cover too much about signature based minting, but you can always click here and read a little bit more about it in our documentations if you choose to do so. We have our NFT drop, which is just your regular ERC721 standard here. And then if we go down a little bit more, we have an NFT collection. So an NFT collection is not going to be a drop. Again, any NFT that you mint to this is going to be owned by the owner of the smart contract. An NFT collection, very similar to a token versus a token drop to an NFT drop. So those are the differences between those. And if you scroll down, if you go down a little bit more, you're going to see this multi-wrap smart contract as well, which is an ERC 721 contract. This is a unique use case contract that allows you to bundle NFTs together and create a new NFT with it. We're not going to cover that in this course, but again, feel free to check out the smart contract, read a little bit more about it. You can look at it in the explore page, just like how we looked at the token contract. But for this, we're going to use this signature drop contract, which is going to create us an ERC 721A contract. Again, just a more gas optimized NFT drop. So coming back to our explore here, we're going to look for that signature drop. We can actually come up into this NFTs tab here and click view all. This is going to show us all the NFT smart contracts that we have to offer. You can see here we have a few other ones from other protocols and developers that you can choose from. But we're going to look for the signature drop contract, which is right down here. So we're going to select that. Again, you can read more about the contract within this page here. You can choose different versions, look at the functionality, the source code, and everything, just like how we covered with the ERC20 token. But in the top right, we're going to hit the deploy now. And here we're going to fill out the same contract parameters similar to what we did with the ERC20 token. So this one, we're going to do a third web ERC 721 NFT. That's what we're going to call it. And then we'll just call it TW 721. And then we can give it a description. We'll say this is an ERC, we'll say 721A smart contract. You can upload an image for your smart contract if you choose to do so. So I can come here. Let me just actually grab a file really quick. We'll grab this file here of this astronaut. That will be the image of my smart contract. We can actually pull this image later on in an application and display that as the image for this smart contract if we choose to do so. Below that, you're going to see something new that we didn't see with the token contract, and that's something called royalties. And royalties are something that you can set for secondary sales of your NFTs from the smart contract. So many times what a lot of people enjoy about NFTs is we can build this royalty system. So when someone sells an NFT from your smart contract through a secondary sale, so like on a marketplace or something, you can set that you receive a percentage of that sale. So what you can set here is the wallet address that that percentage should go to. So you can make it your own wallet address, or if you have another wallet address, you can put that wallet address in there, and then you can put the percentage that you want to claim. So in here, we can say 3%. So every sale, every secondary sale of any NFT within this collection, we will get a 3% royalty, and that 3% will get sent to our wallet here. Primary sale, this is going to be where when we initially sell these NFTs, where is those funds going to go? So again, you can set that to your own wallet address or any other wallet address there. Same at the bottom, network and chain. For this tutorial and for throughout this course, we're going to be using the Mumbai testnet. So I'm going to have that selected. But again, you can choose any EVM compatible blockchain. Just select the drop down and you can search for your network here. So next, we're going to hit deploy now right over here. We'll go through deploying our contract here. You can see we have the gas that we need to pay. So we'll confirm that. And then after that deploys, we'll get a second transaction that pops up asking us to sign in order to import it into our dashboard so that we can view our contract. So here is the second transaction. Again, we'll just scroll to the bottom here and hit sign. And there you go. We have successfully deployed our smart contract, and we have deployed our third web ERC 721 NFT. We're going to deploy one more smart contract before we go over the dashboard here. So I'm going to open up another tab here. Just click on this home here, and we're going to go to browse contracts, and we're going to deploy our final pre-built contract, which is going to be an ERC 1155 smart contract. Now we can take a look back at that documentation again and check out what pre-built smart contracts we have that support that ERC 1155 standard. So the first one here we have is the addition drop. Again, it is a drop, so this is going to be claimable. And then we have another one down here, which is an addition, which again is going to be the non-claimable version of the addition drop. And then right below that, we have one more, which is a pack NFT. So this is actually a pre-built contract where you can create packs and bundle NFTs within those packs. And then when those packs are opened, they reveal the NFTs that were inside them. So you can think of them like trading card packs, but you have pack NFTs in here as well. Now, we're not going to cover pack NFTs within this course, but we do have a few other tutorial videos that goes over a project where we utilize the pack smart contract, and we'll drop that down in the description below so you can check those out. But what we're going to do here in this course and tutorial is deploy an addition drop. So coming here, we're going to look for addition drop. You may see it in the popular section here. If you don't, you can come into the NFTs, hit view all, and we're going to scroll down a bit till we see addition drop down here. We can click on it, and you can see here that the addition drop uses the ERC 1155 standard, also known as semi-fungible tokens. Again, read through, you can check out the source code and functions of this smart contract. But in the top right here, what we're going to do now is deploy now. We're going to, again, fill out the parameters here. So I actually have an image here that I'm going to use, which is a image of like a pass or a key that is going to be our semi-fungible token. And in here, I'm going to write third web, and we're going to do ERC 1155 NFT. We'll make this one a TW 1155, and our description will be this is an ERC 1155 NFT or smart contract. Below that, you have your royalties and primary sales, similar to how we went over with the ERC 721 contract. And again, down here in network and chain, we're going to be using Mumbai. Make sure that is there, and then we're going to hit deploy now. We'll go through the same process of confirming those two transactions. So the first, paying for the gas to deploy the smart contract, and then the second to sign and add it to our dashboard. So once we sign, we'll wait till that finishes, and once it has successfully deployed, we'll be brought to our ERC 1155 dashboard. So we've now deployed our 3 smart contracts, an ERC 20, an ERC 721, and an ERC 1155. Now, once again, you have deployed smart contracts, you'll be brought to your dashboard or your contract dashboard here. And you can view all of the information for your smart contract. So we'll look at this top middle section here. First, you'll see an image of your smart contract. If you added an image for it, you'll see the title of your smart contract right over here. You'll see the network or blockchain that you deployed your smart contract to. You'll have the description of your smart contract that you added. You'll also down here have your smart contract address. So anytime you deploy a smart contract, similar to how your wallet has a wallet address, your contract has an address as well. And that address is just its identifier so that we can identify the smart contract on top of the blockchain it was deployed on. If you want to take a look deeper and in more detail on the transaction that happened on the blockchain, you can hit this button here. Now it will be named differently depending on the blockchain you deployed to. But if we open this Polyscan one here, Polyscan is a site that you can use that allows you to view the interactions of the smart contract or anything that happens on the Polygon, or in this case, the Mumbai blockchain. So we can look in more detail on transactions and things that happen within this smart contract. We're not going to go over that in this course, but just know that that is there and you can always go and check it out. Right over here to the right is a code snippets button, which we're going to cover in just a bit. But this just links to the same code snippets link right here in the left-hand navigation. So scrolling down a bit, each contract is going to have a contract checklist. So this checklist walks you through on the next steps that you have to take in order to complete your contract.
So if we look at our 1155 here, our next step is to first upload our first NFT. It tells us where to go and navigate to in order to do that. If we look at our ERC 721, we have a few more steps from uploading our first NFT to setting the claim condition and then claiming an NFT. And then if we look at our ERC 20, it's minting our first token. So again, this smart contract list here, just a checklist that you can follow in case you don't remember what next steps you have to take in order to complete your contract. To the right of that, you're going to see a card similar to a card that's on the Explore page. If you deployed a pre-built or published contract, you'll see the card of the published contract here. And when you click on it, it just brings you back to that publish contract that we took a look at before, so you can read a little bit more about the contract. And then below the contract checklist, you have some details. So for this ERC 20 here, you see we have our total supply of our tokens, total owned by our connected wallet. In this case, it's both 0 because we haven't created any tokens yet. If we check out our ERC 721, we can check out again total supply claimed, and then total supply unclaimed. And for our ERC 1155, we're not going to see that information in our overview page. We'll actually see that in our specific NFTs, and we'll go over that in just a bit as well. So again, depending on the smart contract that you deployed, you may see similar or different options depending on the smart contract, because each smart contract has its own utility and functionality. Now, what we're going to do is we're going to focus on the ERC 20 smart contract here. So we're going to work on our tokens first. Down here, you can see the latest events. And again, events are, you can think of them as notifications that get stored on the blockchain when certain things or certain interactions happen on your smart contract. And below that, we have permissions. And by default, the one person that has permissions on your smart contract is your wallet that you use to deploy it. Again, permissions are on a wallet basis. Basically, your wallets are your identifiers of who can interact with the smart contract. So what we're going to do here is, if we follow our contract checklist, we have to first mint our tokens. So we're going to head over to the tokens tab and mint our first token. So in the left-hand navigation here, you're going to see under this extensions area, a tokens tab. So we're going to hit on tokens. And here, this is our contract tokens. We see that similar information of total supply and how much is owned by us. We have a few buttons here. You can see 3 of the 4 are disabled. That's because we can't do any of these functions if there are no tokens. But we do have the last button here, which says mint. And mint is just a terminology used in Web3. You can think of it as claiming or creating. So we're going to hit mint here. And we're going to mint some tokens. So we can add however much tokens we want to create to our smart contract. And in this example, we'll just say we're going to mint 1 million tokens. So we're going to put 1 million tokens here is how much we're going to create. And we're going to select the mint tokens. And what that will do is bring up a transaction in our MetaMask here. You can see a little bit about this transaction. We're calling a function called mint2. We do have to, again, pay the gas to mint these tokens. So we can take a look at the gas that we're going to be spending in order to create these tokens. And then we can hit confirm. So this transaction is now calling a function on the smart contract to create or mint 1 million tokens. Now, again, this is a regular token contract. So when we create these tokens are going to be deposited directly into our wallet. So right over here, you can see that was successful. Our total supply is now 1 million tokens, and we own all 1 million of those tokens. We can come over to the left-hand navigation here, and there's actually an events tab here. So we hit the events tab. It shows us the events that have happened on our smart contract. You can see here that the latest event was a tokens minted event and a transfer event. So basically our smart contract minted some tokens and it transferred those tokens to our wallet. So again, you can think of events as notifications. Events also become useful because you can now display these events maybe in your application or something. That way you can prompt a user on or notify them on changes that have happened on your smart contract. So now that we're in our left-hand navigation here, let's go over a few things. So we already went over looked at our overview tab, which shows you an overview of everything about your smart contract. It basically shows mostly everything in this left-hand navigation here. Each link now just shows you a detailed page of what you're trying to look for. So right under overview is your code snippets. We actually saw this within our published contract page. So this shows code snippets on how you can get started to actually use the smart contract within an application. So again, you can see here how to initialize your SDK with your smart contract. And depending on the functionality that you want to do within your application, you can find code snippets here. So transferring tokens, you can see how to transfer tokens and the code needed to do so. In the top right here, you can select your language. So if you're using something like React Native, creating a mobile app, you can see here that the code will change depending on the language you are using. Now in the left-hand navigation here, we're going to skip over Explore really quick. We'll come back to that at the end. We're going to take a look at events again. Again, this is just showing all the events that happen on your smart contract. Below that, we have analytics. Now, this is a beta right now, but once your smart contract starts to have some data going through it, you'll actually be able to see different analytics on your smart contracts, from unique wallets to total transactions, total events, function breakdown, and event breakdown. So you can see the use cases of your functions or events being used on your smart contract. So very useful, especially when it comes to other contracts like maybe your NFT collection contracts. It's a great way to keep track of some of the analytics that are happening for your smart contract. Below that is settings. So here you'll actually be able to customize some of the metadata for your smart contract. So this metadata card here is the same metadata that we inputted when we deployed our smart contract. So if you need to change your description or your name or add an image or something, you can change that here, and then you can update that metadata. You'll have to pay your gas or transaction fee to update it, but it will change that metadata for your contract. Same thing goes for your royalties and primary sales. If you need to change that wallet address or maybe the percentage of your royalties, you can change that in here as well. So again, that settings is just where you can change some of the information that was set when you first deployed your smart contract. Down below that is sources. And this is, again, the source code for your smart contract. You can see all the source code files and take a look at them if you choose to do so. And then lastly, we'll come back up to the Explorer tab here. And the Explorer